Okay, so thank you very much, Arno, and I hope that I actually have a video in here somewhere, so we'll see if that will play. That will be a big test. I stayed away from doing a live software demonstration because that never works. So our work in Work Package 1 was to collect a database of opportunities for geological storage of hydrogen in porous media. So I'm going to briefly describe the database structure, the data that is available in the public domain. Then I will show you a little bit of the database and the geographical information system, and give you a quick summary of the results of Work Package 1. So the aim of Work Package 1 was to produce a European database. So many partners contributed, and I cannot thank them enough for their tireless efforts to bring this together. It's quite challenging to provide something that is almost uniform and presents geological data which is very heterogeneous, both in terms of what the data really says and in terms of its availability. So we collated only publicly available data because under the Clean Hydrogen Programme we wanted to be as open as possible. We wanted our results to be shareable. And we didn't restrict our database at all in terms of the techno-economic aspects. We just said, here is the geology that could be suitable. It's up to the rest of Hystories to decide if it really could be used. And the database feeds from Work Package 1, we collected the geological data and we fed into the other work packages that considered how much hydrogen you might be able to get into those potential stores.
Sorry, we can't hear very well.
Okay. Okay, am I better closer to the microphone? Is that better? Okay, thank you, Ella. So the aim of the database is to highlight regions and sites that may be suitable for development into geological storage of hydrogen. It produced a comprehensive database, which was a very important new knowledge deliverable. And we feel that this could be useful outside of hydrogen storage. We feel that understanding where you have porous media, where you have opportunities to use your geology to help tackle climate targets, we feel that this is important knowledge, and we feel that this could be applicable across many disciplines for hydrogen storage, for CO2 storage, for geothermal, and for many other activities that use the subsurface. So this improved database will enable more accurate assessments of the potential future for green hydrogen storage in Europe. So in order to accommodate the data, we have a three-tiered database. So we looked first for where are the geological formations that might store hydrogen. So where do we have sandstones and limestones? Where do we have porous rocks? And we said, okay, those are very large. So which parts of those might we actually be able to use? So we tried to narrow this down. So we have promising areas, and we called those storage units. And then we have what we called storage traps. And this was where we identified a closure such as a depleted or depleting oil or gas field, or a geological closure in a saline aquifer that might offer us a storage opportunity. So we kept this three-tiered database, and it helped us communicate not only where the data was not available, but also to communicate where we had, where we should be looking in the future. So if we don't have enough data, here is an opportunity to do more investigation and to find the data that you need to make the decisions. So some caveats on the database. So the database contains only publicly available data. So you have to understand that the absence of storage traps in our GIS and our database does not necessarily mean there is no opportunity. It just means that we don't know enough. The data entry format is a little constrained. So geological data is not very friendly. Its rocks are quite interesting, and they don't fit nicely into databases. So you will see sometimes we had to be careful how we communicated. We sometimes found that data will be variable. So for example, if it's an oil or gas field, people will look for the data that tells them about the reservoir and the best bits of the reservoir, and then ignore everything else. So you can get bias in your data because you have more data in the bits that look good, and you can find the reservoir actually looks better than it is when you're trying to use a larger portion. And that interpretation is interpretation. So experts will always disagree very slightly on what things mean. So you have to allow for the fact that this is providing you the information, and now you have to go find out and do the detailed work in order to understand the site fully. So we collected basic geological data, data on the rocks, what's the pore space in there, so what do the gaps in the rocks look like, how much of the rock is space that you can get something into. And we looked at pressure, temperature, things that would control how much hydrogen could be stored. We looked at potential for leakage risks. So we were identifying places in the rocks that looked promising for storage. Is there a risk the hydrogen could escape? So we should discard those as potential sites. And we looked at operational things like how many production wells are there? Is this planned for development for something else? So, for example, if we wanted to use this for hydrogen storage and it was already planned for natural gas storage, we could have a conflict of interest and there would have to be a decision how the storage site might be developed. So in terms of data availability, we found, for example, there was significantly more data for hydrocarbon fields. This is to be expected. They're economically interesting, so people go out and collect more data. We also found that there was detailed data such as well logs and seismic data, in many countries. And in some cases, this was available, you had to buy it. Or in some cases, you would have to do more seismic interpretation. We didn't have the resources in this project. And in some cases, there was an embargo period, so you can only get data that's maybe 10 years old. But overall, the data availability was fair. It was pretty good for hydrocarbon fields, even with the data confidentiality constraints. For saline aquifers, which is basically rocks that contain salty water, not so much. There's far fewer data, and there's plenty more work that we need to do. I should also note that we were joined late on in the project by a partner from Ukraine who also did some assessment work and looked at where there were underground gas storage sites which could be considered for conversion to hydrogen storage. And she was very keen to take part in the project and said that were it not for the difficult situation, she would have been able to communicate much more data. But owing to the ongoing situation, there are some additional confidentiality restrictions. But we were very glad to have a partner from Ukraine. And we also, as Louis mentioned, we saw natural gas storage takes place in most of the countries that were working on the Hystories project. So clearly use of the subsurface is something that we already use this routinely. We can consider this for hydrogen storage. So we had sufficient data to identify geological traps, so real storage sites in 20 of the 22 countries. So we felt this was an excellent result. There was more data available for the hydrocarbon fields and far fewer for the saline aquifers. And detailed data were available for most countries, even if you had to pay for it or even if there was an embargo period. And we felt that this meant that there was plenty more work to be done. And we hope the Clean Hydrogen Partnership might continue to support additional work to investigate opportunities for hydrogen storage in Europe. So rather than showing you a database with lots of rows and lots of numbers, we thought that this would be better to show it in a geographical information system. So this basically is a map where you can select the sites that you're interested in and try to click and to see. We also, thanks to the efforts of Arnaud, brought in the SMRI salt. So we can show where we have salt, where we have porous media, and we can think about where we don't have the opportunity for salt caverns, how porous media stores for hydrogen might develop. So this is the database. You see on the left there is the copyright statement, a little bit about the Hystories project, and a brief description of the database structure. So this will be released very soon. We're just sorting out the final confidentiality statements to make sure that we correctly attribute the data. So it goes from, we have the formations, which are just the large opportunities where we think there might be storage, to the storage units, and to the storage traps. It's thinking very hard, and it might... Well, hey, technology works. So this is the online data. I did a video. As I said, online software demonstrations never work. So you can select all of the countries, and you can look to see the salt deposits. You can look across the whole of Europe and see where the opportunities lie in a pan-European world. And you can also go down to an individual country and then select a trap you're interested in and look at the detailed data. So we tried to collect as much as possible the geological formations, the porosity, the permeability, the depth, everything that would control how much hydrogen storage could be available there. So in terms of the results, so geodata is key in making strategic decisions on the role of the subsurface in meeting climate targets. So having access to data and knowledge to process, manage and manipulate this data will have a wide-ranging impact on the capacity for strategic decision-making. Where geological data are available in the public domain, it's possible to identify opportunities where the subsurface could play a role in meeting climate targets. So for those of us working in geological surveys, please encourage your regulators to make as much data available as possible, because it makes it much easier to identify opportunities. And we found open data tends to bring additional investment, additional interest in the subsurface. And the wealth of data collected during the Hystories project indicates there is significant potential for geological storage of hydrogen in depleted hydrocarbon fields and saline aquifers across Europe. So we identified traps that could be used to store hydrogen. All of the countries, with the exception of Estonia, were able to identify formations and storage units for potential hydrogen storage. So we see that the hydrogen can be stored, and we see that there are lots of opportunities, but the storage opportunities are not evenly distributed and will require varying amounts of effort to realise. So, for example, if we have a depleted gas field, we have a lot of data, we already understand how the site responds to buoyant fluids. Whereas if we have a saline aquifer, this is untested territory, and we will have to do more work to realise this storage opportunity. So next steps, I hope that we can continue this work, and I would very much like to continue our collaboration. So we've collected all of the publicly available data that we can. Next, we still need additional detailed data, and we need site-specific investigations and business cases. All of this is outside the role of Hystories. So we looked across Europe, we looked at some case studies, and now we say, here's the opportunity, please use it. So additional data collection could be taken in a new project to interpret seismic and well data and to collect new data to understand the opportunity offered by saline aquifers. So in summary, Work Package 1 generated a comprehensive pan-European database with opportunities for hydrogen storage. It represents a significant new knowledge deliverable. Public availability of data varies across countries and between different trap types. And an absence of identified traps does not mean there is no opportunity there. It just means that we don't know enough yet. There is significant potential for geological storage, and I will look to my colleague Jan, who will tell us soon to put some numbers on this. And it's to make the point that Erica also made, to say that the traps identified through Hystories, these are opportunities, and they require further investigation and site-specific studies in order to develop them. And then I would just like to thank all the partners in Hystories, and especially all of the partners who have worked with us on Work Package 1 from CO2 GeoNet and our external collaborators. So thank you very much to my partners, and I know many of them are listening online. So thank you, and it was a pleasure to work with you, and we now just have to cross the I's and dot the T's in the report, and then we can say that the work is done. So thank you very much.
Yeah. Questions? Gang Wang from Harvard University. Very interesting work. So I have two questions. So the first question is about, so you talk about reservoir data, and you said it's because it's for hydrocarbon reservoirs and it's biased. So I would be interested to know what other data are particularly useful for implementing hydrogen storage. That's my first question. The second question is, you're talking about absence of trap is not equal to absence of storage potential. So I'm interested that if the typical trap structure is not there, so what other geological structure are you talking about? I mean, how it can be useful for hydrogen storage?
Okay, thank you. So for the first question, in terms of the data that is available, so for hydrocarbon fields, a lot of data is collected in terms of the porosity, permeability, but only about the reservoir. And we have much less information about the seal. And since the hydrogen is such a small molecule and very keen to escape, we would like to see much more data on the seal that could be available. So we would want additional logging data In terms of the storage reservoir, we often find, for example, that they will collect only a bit of core from where the oil or gas is. And if we want to store hydrogen, we might want to use all of the column of sandstone. So we would not know enough about the reservoir itself. And they pick out the core and they pick out the porosity where it looks really good because they're interested in that and where they can get the oil out. And we might find that actually the top of the reservoir where the oil is wonderful and the bottom is not so good. So we can, the difference in availability of data can cause us to misunderstand. And in terms of your second question, so I'm not saying that where there are no traps, we have the opportunity. I'm saying where we have no identified traps does not mean an absence of opportunity. So just because the publicly available data is not enough to tell us something about the rocks doesn't mean that we shouldn't investigate that area. So in the database, we have the formations, the units, and the traps. And where we have the storage units, sometimes that means we know there's a sandstone here. We think that it could be promising for storage, but as yet there's no seismic data, for example. So we cannot see what the topography of the reservoir looks like. We don't know if there are closures. So when I say that just because we haven't got a trap in Hystories, it just means we haven't found a trap. There could be one there. So that's the opportunity that we want to look for.
Thank you very much.
Thank you.
Another question? There is one from the online attendance, otherwise.
Yeah, just maybe a more basic question. So on some of the maps, you had some gray countries, and the question was, is it because they didn't want to cooperate?
No. So when we were invited to take part as CO2 Geonet, we brought as many countries as we could from our association. And I have to say there was one country which was doing a competing proposal, so perhaps did not want to collaborate. So the Hystories is led by TNO, who are a member of CO2 Geonet. So I think perhaps they were already working on something. But no, we had nobody who didn't want to collaborate. Everybody understands the value and wanted to contribute to the database. Thank you.
We have still time for another question. Maybe it was so clear.
I think they didn't hear me at the back because the microphone, you have to be touching it.
Thank you. Thanks a lot, Ceri. So we can